Hello everyone, my name is Rodrigo and alongside my partners Daniel and Jack, we are going to present you our project called Analyzing the Antimicrobial Efficacy of Huitlacoche Extract against Listeria innocua and Salmonella choleraceus. This is our final project for the Food Science Project 2 class. First of all, I'm going to give you some information as background or context so you could understand a little bit more about the basics of our project. Huitlacoche or Ustilagomaides is a biotrophic fungus that attacks maize and causes the corn smut disease, making these big tumors gray purple-ish. Around the world, most countries just discard the corn after the infection, and it is considered detrimental for agriculture. But in Mexico, it is considered a delicacy that has been eaten since ancient times. In the kitchen area of culinary arts, it is already considered the Mexican truffle, and it contains polyphenolic compounds and glycolipids such as ustelagic acid and manosyl erythritol lipids that could potentially be useful against bacteria. Now we need a little context around the problem that we are trying to solve with this project. Foodborne diseases cause millions of illnesses and deaths globally. And as time passes, pathogens have acquired resistance to some of the synthetic preservatives that are now in the market. Ustilagomaides or Huitlacoche's bioactive compounds could fill the need for finding natural alternatives to these preservatives. Now I am going to summarize really quick the steps we follow throughout the semester to complete this project. After buying the Huitlacoche, it was a canned version that it was mixed with onion and other elements. So we first isolate it and mash it to create a paste. Then we suspend everything in ethanol. Our intention was to isolate the extract using a Soxhlet method, but it wasn't possible due to some problems with the chemistry lab. So we just isolate our extract using vacuum filtration. Then we prepare our media. The selective media for Salmonella was bismuth sulfite, for Listeria was Palcam, and for the MIC-MBC part of the project, we use braid card infusion, both agar and broth, because it was a media that worked with both organisms. Then, after having our stock of the disinfectant, we create our serial dilutions, 3%, 1.5%, and 0.5%. These concentrations were chosen based on the manosyl erythritol lipid efficacy against other pathogens like Bacillus subtilis. Then we create our standard subculture of Listeria salmonella around 10 to the power of 7 CFU per ml, using McFarland's standard to calculate this approximate this concentration, and then we start our agar assay plating and the MIC-MBC test. Uh, while plating, we tested at three different incubation temperatures that were room temperature 25, an incubator 35%, and a third incubator that was around 46 degrees Celsius. Mm, with two different incubation times that were 24 hours or 1 day and 1 week of incubation, and the three possible concentrations of disinfectant that I mentioned earlier in this slide. The results are the following.
Now that you have seen our results, let's talk about what they actually means. Because the steroid is the gram-positive, it doesn't have the extra outer membrane that the Salmonella has. That makes it more exposed, so the village extras can reach and damage its cell structures more easily, which helped explain why the steroid was inhibited at the lower concentrations. So we also saw the Salmonella could still grow at the 35 degrees Celsius when the actual level was low. That suggests the temperatures can modulate how powerful the extra is in real foods. That means the both storage temperatures and how much extras we add could matter for keeping the product safe. Overall, our data show a clear concentration-dependent effect, which suggests the idea that the village extras could act as a natural biopreservative if we optimize how it's used. For food manufacturers, this means they could incorporate the village extra into the ready-to-eat meat source or refrigerate food as a natural hurdle to slow down the bacterial growth. Because it comes from the existing agricultural byproducts, these ingredients could also support the sustainability goals by turning waste corn smarts into something useful and profitable. In the long term, this kind of the clean labels antimicrobials could help the companies meet the customer demands for no artificial preservative while still maintaining the food safety and shelf life. Thank you for your listening.